Good morning, good afternoon, good evening to all of you, my dear friends. Welcome to this DADM 3 lecture series, which is data analysis and decision making. And as you know, this course is to do with optimization, operation research, and we will try to cover the whole gamut of courses which we have discussed. And we gave a brief introduction in the first two lectures. So, this is the third lecture in the first week. And as you know, this course is to be run for 12 weeks, which is 60 lectures, and the total combination would be 30 hours. So, each week we will have 5 lectures, and after each week of set of lectures of 5, we will have one assignment. So, technically we will have 12 assignments which are to be solved by the students, and after the end of the course we will basically have the question answer for the final examination. And my good name is Raghunandan Sengupta from the IME department at IIT Kanpur. So, yes, for the last two lectures, lecture 1 and lecture 2, we basically gave a very brief introduction about the syllabus what we will cover, and also I mentioned time and again we may not be able to cover everything, but I will give you a feel and interest would be built up. Then we discuss few references which were not exhaustive in all the sense that they will cover all the topics, but these are interesting textbooks which are well appreciated by the audience in the operation research field. Then we discussed about the ideas of what we mean by operation research optimization. We discussed few of the stalwarts in the historical perspective. I just mentioned the names and where the links can be found out about these researchers. And obviously, I did also mention that this is not the small set of researchers, there are a lot of other researchers who have already worked in operation research and related field. And then I discuss what are very simply what are the assumptions, what are the practical conditions, practicality, and what we mean by linear programming and why it is linear, why the proportionality is important, why additivity is important, why division of the output decision variables are important, and I kept mentioning different examples, whether in the transportation front, with the number of trucks used, with the number of distance covered, total cost, liters of paints produced, and all these things. Or say for example, you are going to take out materials from a square sheet of aluminum and use them to make different components. So, you want to basically minimize the overall loss of aluminum sheet loss. So, with this I will start the third lecture in the first week. So, consider a very simple problem. Now, many of you would definitely be very well aware of operation research and optimization tool, but I will start slowly. So, I will basically discuss a two dimensional problem in the sense there are two decision variables and I want to optimize. Now, I also mentioned that when you are doing optimization, the techniques would be discussed here in a general format, but how you formulate the problem, what are the conditions, what are the decision variables, whether decision variables are continuous, whether they are integer, whether they are 0 1 type, or whether you have a quadratic optimization for the objective function, whatever they are, that will basically come from the practicality of the situation based on which you are trying to utilize the problem. So, this practicality of the situation, experience, feel has to be acquired through experience, acquired through more reading. So, this has to be done time and again. So, we will try to basically lay stress on that in some manner such that somebody is able to tackle the optimization problem formulation as such, while the solution techniques are led straight down rules which we will try to discuss in the proceeding lectures for this course or NPTEL MOOC series. So, consider Mr. Lakriwala and company produces inexperienced tables and chairs. So, you produce tables and chairs to sell in the market, and Mr. Lakriwala basically as a company acquires the wood or plywood, whatever it is, of different qualities. So, I am not going to the quality because that will basically bring the concept of what different type of tables and chairs would be utilized. So, the production process, whichever the production process is, for each is similar to that with both required some numbers of hours of carpentry work. So, they are the carpenters work and they produce the general framework of the tables and the chairs. And after and they use certain number of labor hours. So, it may be 2 hours, 3 hours, 4 hours, some amount of labor hours is required. And after the chair is put into place, it has been the sitting place, the arm rest and all these things have been done. It goes into painting and varnishing to basically bring a good look, longevity should be increased. Now, a general study has been done by Mr. Lakriwal and company, the company manager or the workers or the general manager, whoever it is. So, each table will take 4 hours of carpentry work. So, I am considering 4 hours of carpentry work basically coming from combined effort. So, it need not be one person is working continuously 4 hours, it may be combination of different person working for different components, but the total number of hours is 4. And we will also consider simplistically that if one person works for 4 hours, so multiple person also combined together also works for 4 hours. So, we would not consider that division of labor is coming out such that the efficiency is increasing, we would not take that. So, each table takes 4 hours of carpentry and 2 hours of painting and varnishing. So, in the same way, if it takes 2 hours for painting and varnishing, we will consider that if it is a one person, he or she takes 2 hours to paint and varnish, or if there are multiple person, the combined effort which is being put by this multiple person should add up to basically 2 hours. Similarly, when we go to the chair, so each chair requires 3 hours in carpentry. In the same way, whether one person is working or multiple persons are working for the chair, it takes 3 hours. So, we will consider the 3 hours to be true, both multiple divisional labor to be true and one person to be working. And similarly, when the chair is finished, it needs to be painted, varnished, and the total number of hours required to varnish or paint one chair is 1 hour. Again, as per the assumptions, as per the norm, we will consider that this work which is being done for carpentry or varnishing for the chair or the table is being done on an individual basis or on the different persons depending on the concept of division of labor, but it would not affect the number of hours would not change and they have been stated. Now, remember one thing that we when we are saying each table and each chair we will consider they are the same type. So, any variation in the design, variation of the upholstery and all these things we would not consider that. So, the current production period which is totally utilized. So, this total utilization would be consider it can be 1 week, it can be. So, obviously, 240 cannot be in 1 week. So, it can be few months or 1 year whatever it is, we will consider the total collective time which is available for the carpentry and the total collective time which is available for the varnishing and finishing or painting. So, it will be 240 hours for the carpentry and it will be basically 100 hours for the painting and varnishing. Again, we will consider it is a collective time being taken by different individuals or one person working continuously would be basically spending this 240 and 100 hours and it will be same whether collective effort is being put or an individual effort is put. Now, obviously, once the work is finished, Mr. Lakriwala and company would like to sell this product in the market and when they go to sell this market, we will consider only the profits. Now, this is important to understand that we are not going to consider for the time being for the problem, we are not going to consider what are the cost and what are the cost of the material and what is the actual production cost or the purchase of the raw materials or what is the selling price. We will only consider the profit which is the price, extra price which you will get from buying and selling this product, buying the raw materials and basically selling the finished product. So, they are given as Indian rupees 7,000 for each table and Indian rupees 5,000 would be there for each chair, that is the profit which you have. Mr. Lakriwala and company is to determine the best possible combination of the chairs and tables. So, the best possible combination of chairs table it basically means that what is the number of chairs or how many number of chairs or how many number of tables you are going to produce such that you meet some criteria. So, obviously, this criteria would be dictated depending on what is the business output and what is the general business norm based on which this Mr. Lakriwala and company is running the business. So, let me read it in the last point. So, Mr. Lakriwala and company is to determine the best possible combinations of chairs and tables, and obviously, they would be integers. So, if you remember one thing that I mentioned, that for the linear programming problem, even though we have considered the divisibility of the decision variables are possible in the theoretical sense, in the practical sense it may not be possible. As you are seeing it, that we cannot produce 2.3 number of chairs or 4.7 number of tables, we will consider them to be actually in the case they are integer values, but in the for the problem sake we will consider them to be continuous values which are greater than 0, and greater than 0 just does make sense, but because we are not going to produce less than 0 number of chairs or 0 number of tables. So, obviously, this company's main problem or main issue is to find out the number of chairs and the tables it should manufacture and sell in the market, such that is able to sell them at the highest profit and such that the total cumulative profit is basically maximized. So, your main query would be what is the number of chairs, what is the number of tables you should produce considering the profit which you have for the chairs and the tables and the total amount of time to be spent which you have for producing the chair and the table, based on which we will basically find that what will be your total profit for the production. So, if I consider the total scenario, so if the scenario is being stated here as a matrix. So, these are the hours required for the production, and remember that when I am mentioning the hours, it will be on a per unit basis. So, that per unit basis may be in numbers and may be in weeks, may be in years and whatever it is. So, if the department is carpentry or the work shade is under carpentry, so it will basically require 4 hours for each tables and 3 hours for each chair on the carpentry front, and if the painting and varnishing work is done, per table and per chair the corresponding timing would be required to finish it would be 2 and 1. And again remember, I am repeating it, please bear with me, that whether it is individual time or a collective time would not matter, because we will consider them to be same, whether collective time is being utilized or whether individual timing is being utilized. Now, if you remember, I did mention that total number of hours which is available for carpentry was 240, total number of hours which was available for painting and varnishing 100. So, if you check the last column, so these basically states the available number of hours in totality in a fixed time span. It does not mean that for infinite time variations I have basically only 240 hours. It may be, say for example, per unit time, that may be either 1 year or 6 months, whatever it is. We have maximum available is 240 for the carpentry and 100 for the painting and varnishing. Now, we have also mentioned that what is the profit without considering the cost and the selling price. The profits were basically based on Indian rupees was 7,000 and 5,000 for the tables and the chair, each table and chair which are being sold in the market. Now, your actual idea was basically to formulate a problem, formulate the optimization problem such that you want to basically maximize the profit. So, profit is what is the main motivation based on which Mr. Lakriwala and company is working. So, the constraints are the hours of carpentry time used cannot exceed 240 per hour per week. So, here the time frame of per week is going to come. So, whatever number of carpentry work which you do, whatever number of chairs you produce, whatever number of tables which you produce, the total amount of time which is there for you for doing the carpentry work is basically 240 hours per week, nothing more. So, obviously, if you spend 228 number of hours, that means you will basically have an extra amount of hours per week which cannot be basically utilized, that will be basically 240 minus the total number of hours which is being actually utilized. On the same way, the hours for painting and varnishing used cannot exceed 100 hours. So, per week. So, in the same logic we will consider that if you are basically trying to utilize the resources to paint and varnish, you cannot in a week have more than 100 number of hours for work for this particular work which is painting and varnishing. So, now basically let us denote the variables which are the decision variables. So, let us denote the decision variables as T and C as the number of tables produced per week, because this is important to remember that the time constraint based on which you have found out the 240 hours and 100 hours is based on a weekly basis. So, in the same context we will try to basically mention the variable T and C, which is the decision variables, are to be found out for a weekly basis, and based on that you can basically find out that what is the total number of production on a yearly basis or on the semi-annual basis, and so on and so forth. So, if T and C are the number of tables and chairs produced, so you want to basically find out what is the optimization problem. So, obviously it will come that if each table is being sold for 7,000, then the profit which you will get for selling T number of tables will be 7,000 into T, which I will now mark here. So, this is 7,000 into T. Now, when I come to the chairs, it has already been mentioned it will be 5,000 per chair sold in the market. So, obviously, this is also known to us, is 5,000 into C. So, obviously, we will try to basically find out those values of T and those values of C, which will give us the maximum value of the profit based on which this company can operate to find out the number of chairs and the number of tables it will basically manufacture. So, mathematical relationship to describe the two constraints would basically now be discussed, or basically we will try to find out the answer. So, one common relationship is that resources used is to be less than or equal to the amount of resource which is available. So, if I want to basically utilize x amount of money for different type of utilization, so my total number of availability of the resources would definitely be greater than the total number of x's based on which we are trying to basically operate, considering that there would not be any other demand for the same product. So, if I come to the constraints, so these are the constraints which we will discuss. In case of carpentry department, the total time required is, so now let us go back. So, per table we need 4 hours. So, if the total number of tables is T, so the total number of hours utilized for manufacturing T number of tables is 4T. So, that is point 1. So, in the similar way, per chair utilization or number of hours utilization to produce one chair is 3. So, if I basically multiply 3 into the number of chairs which are being produced, so you will basically find out the total time which is being devoted to find out the total production, which is T number of chairs, and separately we will find out what is the total time required for producing C number of chairs. Now, if that is the case, obviously you will try to find out that in the carpentry workshop what was the total requirement of number of hours which you have. So, obviously you will immediately say that is 240 hours. So, if that is the case, then the total sum of the total number of hours which are being utilized in the carpentry section for separately for the chair and separately for the table, when they add up, obviously should be less than equal to 240, because any utilization more than that would not basically make any feasible sense. So, if I basically highlight that, so 4T plus 3C is less than equal to 240 depending on the carpentry one. So, in the similar way, when I come to basically the painting and the varnishing one, so the total amount of hours required for this painting and varnishing one would be 2 into T plus 1 into C. So, this 2 is basically the total number of hours which is required for painting and varnishing by one table, and if I consider trying to basically find out varnishing and painting for one chair, it will basically 1 hour. So, this is the value of 1 which you have. So, again if I go back to the problem, I have the total number of hours which is available for us is 100. So, hence the total combined amount of hours which we will have for us would basically be, the first equation is 4T plus 3C is less than equal to 240, and the second one is basically 2T plus 1C is less than equal to 100. So, continuing with the problem, hence this constraints present production capacity restriction which affects the total profit. So, Mr. Lakriwala and company cannot produce 80 tables during the period if T is equal to constraint, is basically to be violated. So, what we will try to basically understand is that depending on the output which you have, we will try to basically find out how the solutions can be found out. So, this solution basically I will try to basically go it slowly and try to do it graphically in order to make you understand, because the graphical concept will give you an idea that how does the algorithm work for the search techniques of the linear programming concept or the simplex method, which we will try to solve. Okay, let us do it here, so it will be easy for us to do. So, what are the constraints? So, let me write out the objective function. So, I will use so what is the objective function? 7000 T plus 5000 C. Now, the constraints are so the constraint will basically come for the carpentry and the varnishing. So, carpentry and varnishing 40 plus 3C is less than equal to 240. 4T plus 3C is less than equal to 240, and 2T plus 1C is less than equal to 100. So, this is the second constraint, and this would be so. Now, this we will try to solve it, and remember T and C, as I have already discussed, R is basically greater than 0, which is the non-negative part. So, let us try to basically formulate the problem. So, obviously non-negative. So, any values of T and C which are in either the second quadrant or the third quadrant or the fourth quadrant would basically be ignored. So, you will only consider the emphasis being there on the first first quadrant only. Now, consider the values as so I will basically draw. So, if I consider the first equation, it says that T and C, if they are 0, it is less than 240. So, obviously 40 is about 60. So, I will be okay, basically I mark T and C here. So, 40 is T is 60 and C is 0, 10, 20, 30, 40, 50, 60. So, these are considered as 20, 40, 60. This is the one, and then if you consider C, it basically with T as 0, it will basically be 80. So, 10, 20, 40, 60, 80. So, this is the point. So, if I now 0 basically affects it. So, the portion so this is the first part. So, this is the feasible part for the first. So, I will write it down. The second one is T. If you put C as 0, T would be 50. So, T is 50 is here. And if I put C value with t is equal to 0, I basically get 100, 20, 40, 60, 80, it's just 100. Again 0 value is basically be met. So, if I consider now for this person, this is the feasible set, but if I consider the joint one, so it will basically be of different color. So, your total area this is A, this is A prime, this is O, this is B, B prime. Now, look at this problem. Technically, the triangle, not the triangle, the figure A dash O B and okay, let me mention this is C also. So, this C would not do because C is a, so let me put it as D. So, D is basically the figure A dash O B and D is basically the actual feasible region where you can find the solution. But the question is that if I ask you that you are as a layman and I ask you that what is the best solution. So, technically how many such feasible solutions are? So, obviously we will say that whole set starting from A dash O, B and D is feasible, which means there are infinite such points. Now, step back, if you remember I did mention about one person when we were discussing the second class by the name of Karmakar. So, he basically proposed the interior point algorithm where the search set basically now shrinks to only the corner points which are O, B, D and A dash. That means, infinite searches have basically now come down to only 4. Now, what you need to do technically, you basically need to find out each and every points. So, what is the coordinate of A star, A dash, O, B and D, find out what is T and C, plug them in the objective function and solve them to find out that what is the objective function value, then rank them from the highest to the lowest and take the decisions accordingly. So, this is the J-learn framework. I will discuss the problems more so in the 4th lecture depending on how the progress is. Have a nice day and thank you very much.